Hey there, Science Explorers. Welcome to today's lesson, Blinded by the Light. Our objective today is that Science Explorers will investigate to understand the different properties of light. Light. So, here's our key vocabulary for today. It looks like a long list, so let's get through this. Our first vocabulary word is to absorb. Now, if something is absorbed, it's to take it in or to suck it up. Refraction is the bending of light. Reflection is when light bounces off of an object. For example, a mirror. A mirror reflects light, right? This next one's is probably your art teacher's favorite. Roy G. Biv, ROYGBIV, right? It's an acronym for the visible spectrum of light. Or colors, as we know, red, orange, yellow, green, blue, indigo, and violet. The colors in the visible spectrum are always in the same order due to their different wavelengths. Then we have a prism. Prism is a piece of glass or plastic, usually shaped as a triangle, used for separating white light passed through it into a spectrum or for reflecting beams of light. And then we have those two words together, visible spectrum. The visible spectrum is the portion of the electromagnetic spectrum that we can see. This is called visible light or just light. A wavelength. The wavelength is the distance between repeating units of a wave pattern. For example, crest of a wave to the crest of the second wave. So the wavelength. Right? So, what is light? What do you think light is? Well, light is a form of energy. It travels very fast. As a matter of fact, it travels 186,000 miles per second in a straight line. As far as we know, nothing travels faster than light. So here's a fun fact. How long do you think it takes the light from the sun to reach Earth? Think about that. How long does it take for the sunlight, the light that's traveling from the sun, how long does it take to get to Earth? Yeah, if you guessed 8 minutes, 8 minutes. It's about 8 minutes long. So the light that's reaching us here on planet Earth is actually 8 minutes old. It left 8 minutes ago. Light travels in waves, and it can be defined by its wavelength and frequency. Frequency means how fast the wave vibrates or goes up and down. Wavelength is the distance between the two peaks of a wave. Light travels in a straight line, and when it hits something, one of three things can happen. Light can strike an object and be absorbed, causing a shadow. Light can strike an object and be reflected, as in a mirror. It can be bounced in a different direction. And then light can strike something like water or glass, causing it to slow down and refract or bend. Okay, it'll shoot off in a different direction. What makes us see different colors? Well, the colors we see are a result of reflected light. For example, the petals of a red rose are reflecting red light and absorbing all the other colors. If an object reflects all colors equally, it will appear as white. If an object absorbs most of the light falling on it, it will appear black. The primary colors are red, yellow, and blue. All other colors, referred to as secondary colors, are a result of various combinations of primary colors. Let's do some investigations with the properties of light to see what happens when light is absorbed, reflected, and refracted. Activity number 1. How is light absorbed? All right, Science Explorers, here we are in Data Dietrich's second floor hallway. I have my lovely assistants, Magma Madison, Helium Hayden with me. What we're going to do is we're going to do a little bit of experiments on how light is absorbed. And the way we're going to do that is we're going to take a look at some shadow puppets. Okay, hit it. All right, so here we go. We're gonna come over here to our blank wall, and I think Magma Madison's gonna go first. Magma Madison, which one? What are you gonna do here?
I'm gonna do a dog.
Okay, so there's Magma Madison's dog. Check out the cool shadow. It's kind of like the longest ears. It's kind of like Pluto almost.
Yeah.
All right, so there's one hand puppet. Okay, Helium Hayden, come on over to the wall. All right, look at that. It's either a butterfly, a bird, or a bat. I can't tell, but it's pretty awesome.
Ooh, it does look like a bat.
What happens here, Science Explorers, is that I'm shining the light on the hands of our Science Explorer friends here. And what's happening is, since their hands are solid, they absorb the light. That's why the shadow is created, because the light won't pass through, okay? Feel free to keep experimenting with your shadow puppets. Let me show you my magnificent skill of shadow puppeting. Hold on, I gotta get my hands right, okay? Maybe I can do this one. Hold on, ready? Okay, it's a birthday bear. Can you believe I did that with my hands? That's amazing. That's pretty incredible right there. All right, that's it for activity number 1. Join us for activity number 2. Activity number 2, how is light refracted? All right, Science Explorers, here we are at activity number 2. Activity number 2 is, how is light refracted? Okay, light refraction is when the light passes through something and it gets dispersed. It gets taken apart. Think of a prism, okay? So, the reason why it's a little darker in here is because it works best in the dark. A prism, like I just said, is a piece of glass or plastic. In this instance, we have a little piece of plastic that looks like a prism, okay? And it almost looks like something that you would find on like a chandelier. There's even like a place where maybe we can wear it as a necklace. Who knows? So its purpose is that it can bend and refract light. In doing so, it separates light into the different colors. So what we're going to do is we're going to take our prism, we're going to take our flashlight, and we're going to shine it through to see what happens to the light. Are you guys ready? Okay, so let's go down here. Okay, I have my flashlight. I have my prism. There's the light. Now watch what happens when I pass the light through the little prism. You want to try to hold it close to the prism, and then the prism, not too far from the paper, but you can see that in certain places, as it passes through, if you can see under here at my pinky right there on that paper, the light that passes through looks more like a rainbow now, right? It's pretty neat to see how it's even. I had to hold the flashlight with my mouth there, so I finally stopped talking. Impressive, right? So you can play around with like the different placement of the prism, the different placement of the flashlight, how far, how close. If you're too close, you're not going to see much. If you pull away just slightly, you start to see the rainbows and the different refracted light. You can give it a turn to see how it does it different. Check that out. That's like almost like a little like ceiling projector for like when you're going to sleep. That's pretty neat, right? Visible light or white light is composed of several different colors that can be refracted by a prism, or this right here. A prism refracts or bends white light from the sun or another light source. It refracts them into the colors of the rainbow. When conditions are right in the air, water droplets in the clouds can work like a prism and separate sunlight into, you guessed it, a rainbow. Which scientists first discovered that light was actually made up of different colors. Isaac Newton. It was in 1665. He was studying at Cambridge University in England, and one sunny day, Newton took a glass prism and placed it in the sunlight. The result of the spectacular multicolored band of light that looked just like a rainbow. Okay, Newton then I believe that visible light or white light was in fact made up of a rainbow of colors. And if this was true, he thought that he should be able to recombine the colors to make light white again. To test his idea, he placed another prism upside down in front of the first prism, and he was right. Okay, and the band of colors recombined again to white light, proving white light is a combination of colors. Isn't that incredible? All right, so that is it for activity number 2. Let's go check out activity number 3. Activity number 3 is a refraction demo. Activity number 3, refraction demo. Okay, science explorers, here we go. Activity number 3, this is a refraction demo. You're gonna have a cup or a container and a pencil. All right, so I'm gonna take this pencil and I'm going to put it inside the cup. Now, when I hold it there up against the edge, does it look different at all? It looks like a normal pencil, right? Nothing really changes besides the fact that it's in a plastic container, right? Okay, so let's scooch down here and let's take a look and see what happens. What I'm going to do is I'm going to add some water to our container here, okay? And I want you to tell me if something changes. Here we go, about maybe halfway. Perfect. It's a little less than halfway, but close enough. Okay, so what happens? Does it look different? What do you think? If you come closer, does it look different? What if I hold it to the side? Does something change? Okay, from where I'm looking at it, it kind of looks bigger in the water, right? It kind of looks like the pencil expands, but when I lift it up, that's not the case, right? It's still the same size. Okay, check that out. All right, moving it around. When I lay it like that, it kind of looks like it's chopped. The bigger end that's in the water is like back a little further, and it's pretty neat to see, okay? It's almost kind of like a magic trick, yeah? You guys see that? I hope you can see it on the camera. When viewing the pencil outside of the container and through the empty container, the pencil looks normal, okay? When viewing the pencil through the container of water, the pencil looks to be crooked almost and gets kind of like jagged. This is because light reflects off the pencil in a straight line as you look at it through an empty container. However, when water is added, the light bends and refracts. Sorry, it refracts as it passes through the water, and the pencil looks crooked. Isn't that neat? It's all about the water, and it's all about how the water is refracting light. Mind blown. Does my head look different? I don't know. That's pretty cool. All right, that takes us to activity number 4. Activity number 4 is, how is light reflected? Activity number 4, how is light reflected? All right, science explorers, here we are. We're gonna have some fun with some mirrors, and we're gonna see how light is reflected. Now, when light is shined off of an object that, can reflect light, it bounces off and goes to another place. It's different than refraction. Refraction is when the light is separated. Reflection is when it bounces. So the way we're going to demonstrate this is we have a laser pointer, right? So check it out. There's my laser pointer, right? Okay. And here's my lovely assistant. What's your name?
Magma Madison.
Magma Madison. That's right. Magma Madison. She loves it. Okay, so when I shine this off of the mirror, I can bounce it off the mirror onto the table, which is pretty neat, right? I'm reflecting the light, Okay? Same thing with the flashlight function. If you want to, you can reflect the white light as well, not just like the red laser. Okay? Oh no.
Uh-oh.
Oh no.
Uh-oh.
Oh, it's back. It's back. Okay. So, what we're going to try to do is we're going to try to make a little laser maze. So, I'm going to try to reflect my laser off of a mirror into another mirror, and we're going to see if Magma Madison can catch it on her mirror and move it again. Ready? Here we go. You're probably going to stay that way a little bit. Let's see where it bounces. You can see when the dot is on the mirror, you know it's bouncing, and it's bouncing off my camera person's chest right now, which is pretty funny. Helium Hayden over there. She's laughing. She's having a good time. She's feeling it. Oh man, what's going on with my laser?
Uh-oh.
Uh-oh, indeed. Oh, I think the battery compartment was loose. That's what was going on. I fixed it. I scienced it. Whoa, light. Okay, here we go. I'm still bouncing. Oh, wait. I think I just saw it on Magma Madison's hair. Look at your hair. It's it's on your hair. So now you gotta take your mirror over there. Okay. Now, where your mirror is putting it, we'll have to find out. Okay. It takes a lot of good placement to get.
Oh, it's over there.
Nope, that's not it. That's where it's bouncing.
Oh, it's
off
on
of here.
you.
It's on me. Okay, I'm gonna catch it. Hold still. I got it. I got it on Helium Hayden's forehead over there. Look at that. Look at that. Oh boy. Helium Hayden, you take that and try to bounce it back to me. I don't know. Let's see.
Come on, Hayden.
Ready? All right. Turn the mirror the other way.
The other way.
Stay with me. Oh, is it on me now? We just bounced the laser around the room. That's crazy.
Where is it?
It was on me for a little bit. Oh, man. What we're challenging you to do is to see if you can make a bigger mirror maze than we did. So, again, if you look here again, maybe we can do a simple one. Magma Madison, can you hold that one?
Mm-hmm.
Okay, whoops, wrong one again. Okay, so, oh boy.
Uh-oh.
Ha! Ta-da!
Yay!
Should be on the ceiling or something, I don't know.
It's over there.
Oh, it's on the wall behind me. Again, when the light from the laser goes through and it reflects off of the mirror and it bounces around and it's being reflected, okay? Most mirrors must be specific angles and places for the reflection from one place to another, okay? You've probably seen it in movies. You've probably seen it happen where they used it to bounce them around, or maybe a super secret James Bond Ethan Hunt spy used it to stop a mirror, a laser from like passing through, and it bounced back so it didn't trigger the security. It's way harder than they make it look. Okay.
That's magic.
So usually it'll bounce off a nice shiny smooth surface. Okay. And that's your activity number 4. Activity number 5 should be another fun one with some mirrors and reflecting and refracting. We're going to do our own kaleidoscope build. Activity number 5, build a kaleidoscope. All right, Science Explorers, here we are, our final activity for the day, building a kaleidoscope. So you're going to get a kaleidoscope kit, which is going to involve this mirror kind of paper, okay? A tube that kind of looks like an in-between of a toilet paper roll and a paper towel roll. There's going to be a smaller piece of tubing. There's going to be a frosted piece of plastic, which I had already taped onto my tubing, and then a clear piece of plastic. You're going to need tape, you're going to need beads, and you're going to need the other piece of cap to seal the top, and that's what you will look through then. Okay? You guys ready?
Yep.
Okay. Who's on bead duty? You're going to be on bead duty? You be on bead duty, you be on tape duty, okay? So, the first thing you're going to do is, and again, I pre-folded this to try to simplify our video here, but you're going to get this as flat. You're going to want to fold it into thirds, okay? And when you fold it into thirds, really press that crease down because it'll still kind of pop up. And what you're trying to create here is a triangle, okay? So, Magma Madison's going to hand me a piece of tape here. You're going to take the tape and you're going to tape over the edge to create that triangle we're looking for. Okay, another piece, please. All right. You know what? We're going to do 3. Just to secure it. That much better. Okay? Man, never in my wildest dreams could I ever think I was going to make my own kaleidoscope.
Yeah.
I always thought they were so cool as a kid. Okay, here's my triangle. There's my triangle. Check that out.
Yeah.
Right? You can barely tell we taped that thing. All right, our triangle and our, for lack of better terms, toilet paper tube, is going like that. So it's going to go inside. Check that out. Look at that. What do you think so far?
Yeah.
If I look through it, I see cool things. Check that out. Look at that. Look at it. Whoa.
Oh, wow.
Whoa. That's only the beginning. All right. You're going to take this piece right here, which is your, it's like where you're going to look through. We're going to tape that to the top. So, Magma Madison, again, please. All right. We're going to make it sure get it nice and secure on the top. Do not tape over the hole. You can go like this and tape down. Just don't go over the hole, okay? You want to get it nice and secure on there. So that way, your kaleidoscope doesn't fall apart. Okay? One more, please. Thanks. I'm gonna do this one this way. Just because.
Ooh.
Symmetry. Ooh, symmetry. All a part of STEM, folks. All a part of STEM. So now I have, you know, our little peephole there. Our looking hole. Right there. Okay? If you do that, it'll fall out. So you gotta be careful. Next order of business is to tape on the frosted piece of plastic. Okay? Now, like I said, I had already started that piece. And I have that piece taped on already. What Helium Hayden is going to do is she's going to put some beads into there now. And what I'd like for Magma Madison to do is to, you know what? I think I'm going to tape it this way. Nope, I'll do it the other way. You put the beads in there. And Magma Madison's going to preload me with some tape over here. All right? Are you being very specific about what beads we put in there? Okay. A couple more. Just enough to line the bottoms. Okay. Good? Great. Looks fantastic. Look at that. We didn't have to fill it all the way. Just get a nice...
little bit in there.
Yeah. You don't need to fill it all the way. It does not need to be filled all the way. Folks. All right, so that's all the tape I'm going to put on there because I have to tape it again on to here. So, Magma Madison, please. You can give me some longer strips because what we're going to do is we're going to seal up this whole side right there. Yeah. 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 Helium Hayden's excited. I'm excited. Who's looking first?
I am.
Oh, do we go oldest first?
Youngest shall go first.
Because then
Oldest.
it should be me.
Youngest shall go
Dang.
first.
So I guess we go youngest, huh?
Yeah.
All right. You do the honors. Look through that.
Oh my gosh, it looks so awesome.
Oh my gosh, it looks so awesome.
Whoa.
What?
That's so cool.
Oh man, you gotta give it a turn. Oh, that's
A
even
turn?
neater. Look at that.
I didn't think of
Oh
that.
man. All right. So, my friends, I don't know if we can pull this off. Okay, let's see if we can get in there. Can you see it? Oh, wow. We are good. My camera person is on point.
Ah.
What do you think? Huh? What would happen if I did this?
Oh.
See it better? Oh, yeah.
Oh. Can we do that? No,
Oh,
dude. We
gosh.
have it.
All right. So, we have one bonus activity to do, and we'll see you over there. We're gonna try to see if we can write using a mirror.
Ooh.
Mirror writing.
Wow.
Activity number 6, mirror writing challenge. All right, guys, here's our bonus activity, our extra activity. We're gonna do some mirror writing. It's a mirror writing challenge. When we look in the mirror, we see like the flipped image of something, right? I see my face, but it's flipped, right? What you're going to do is you're going to take your mirror from previous activity, and I would show you the mirror side, but my camera person said no. You're going to use the mirror, right? And you're going to hold the mirror side down like the brim of a hat, okay? Underneath there, I have a piece of paper. Your goal is to look up at the brim of your hat and write on the piece of paper down here, okay? It's not going to be easy, okay? So, I don't know if my camera person can get me doing this whole thing so you can see my eyes and know that I'm not cheating. I'm going to look up in the mirror and I'm going to write my name. Oh boy. I'm writing on a diagonal. Oh boy. Yeah, it's not easy, right? Oh. I did way better of this when I practiced it by myself. Okay. Oh, wow. Data Dietrich. Not too bad, right? I don't know. Whew, that's an upside down T. I'm shocked that it went as well as it did. I know I can write my government name or my government nickname there. I can write Mike pretty easily. For you, those of you who know my secret identity. Nope, I messed up the K. Oh, I'm overthinking it. Oh man. Oh gosh. Nope. I'm getting worse as time goes on. So the challenge is for you guys to be able to play around with this. The reason why it's so tricky is because what your brain is seeing in the mirror is not the same signal that your hand is used to getting. And it's like, okay, wait, what are you doing? So, I mean, you could do things like draw a smiley face, which I'm hoping doesn't turn out. Oh, it almost turned out as a frowny face. It's more like a meh face. Meh. You could try to draw a house. Oh boy. And the comedy will continue because, again, you know, as my motto goes, I'll say it in a minute. This brings us to the end. And folks, I hope you enjoyed it because here at Science Explorers, if it's not fun, guess what? We're not doing it.